Assalamu alaikum. This is chemistry 11th, and our today's topic is about statistics of matter. Now, before going through this topic, I would like to give you some information regarding this. These would like to discuss these intermolecular forces. Now, as far as these intermolecular forces are concerned, these intermolecular forces, they are both attractive as well as repulsive in nature. And these intermolecular forces, they do not include electrostatic forces of attraction, which we see in case of ionic compounds, where we see the force existing between these cations and anions in case of these ionic compounds, which are electrostatic in nature. So these forces are not included in these intermolecular forces. Now, these intermolecular forces, there are different types. We have got these dipolar forces, or the dipole forces. Then we have got another type of these intermolecular forces, that is ion dipolar forces, or ion dipole interactions. Then we have got one more type, that is ion induced dipolar interactions. Then another type of these intermolecular forces is instantaneous. It is instantaneous dipolar interactions. Now, collectively, these are called as these the four types of forces which I have told you. They are collectively, they are called as van der Waals forces. This is in honor of a Dutch scientist, van der Waal. And now, as far as hydrogen bonding is concerned, which, although hydrogen bonding is dipolar in nature, this is hydrogen bonding is also not included in these intermolecular forces. Now, as far as the dipole forces are concerned, these forces, you can see I have shown here. These forces are present in polar covalent bonds with a permanent this dipole momentus. Now, in this case, we see the shared pair of electron it is displaced slightly towards the more electronegative negative this atom, which develops a slight or partial negative charge, while the other atom that develops a slight this positive or partial positive charge. Now, in these molecules, we see the oppositely charged ends of the molecules, they mutually attract, resulting in dipole interactions. Now, these dipole interactions, they are present in the molecules of hydrogen colloid. You can see this is a hydrogen colloid. I have shown here how these molecules, the oppositely charged ends of the molecules, they attract each other when they approach each other. Now, since the bond between ACl, it is polar in nature, since electronegativity of this chlorine is more than that of the hydrogen atom, so hydrogen develops a partial positive charge, whereas this chlorine atom, it develops a slight negative charge. So the positive end of the one this molecule, you can see here ACl, it is attracted towards the negative end of the other this ACl molecule. So in this way, these oppositely charged ends of the molecules, and they mutually attract each other, and giving rise to these dipole interactions. Now, dipole interactions, as I have told you, since as you can see here. Now, the magnitude of the positive or the negative charge in these molecules, it is less than the unit charge, that is equal to unit charge, which is equal to 1.6 into 10 to the power minus 19 coulombs. Also, this interaction energy in this case, in these molecules, when the oppositely charged ends approach each other, it is inversely related to 1 by square of the radius raised to the power 6. That is 1, where r is the radius raised to power 6, where r is the distance between the polar molecules which are involved in these dipole interactions. Then we have got another type of these intermolecular forces, that is ion dipole interaction. Now, as far as these ion dipole interactions are concerned, the name itself suggests it involves ions, which may be cations, or these may be anions, and the polar molecules. Now, this ion, whether it is positive or it is anion, and it is attracted towards the oppositely charged end of the dipolar molecule, and it is strength, it depends upon the charge and the size of the ion. Now both cations, since both cations and anions, they have got the same charge, but since cation is smaller in size, cation interacts more strongly than anion because of its small size and high this charge density. You can see here, I have shown here, this is a cation, and this is cation dipole interaction. So in this case we see sodium ion, you can see this is a dipolar molecule, this water molecule. This the negatively charged end of this water molecule, it is attracted towards this cation. Similarly, you can see this water molecule, negative end of this water molecule, it is attracted towards this cation. Then we have got, now you can see here how these negatively charged ends of these water molecules, they are attracted towards this cation. Similarly, you can see here in this case I have shown here, this is a chloride ion, it is negatively charged. Now the positively charged ends of these of the water molecule, you can see that since the two hydrogen atoms, they have got a slight positive charge, now they are attracted towards these towards this negatively charged this anion. Similarly, in which in all these water molecules, the positively charged ends of these water molecules, they are attracted towards this anion which is negatively charged. Now since this NaCl, it is highly soluble, as we know that it is highly soluble in water, because both cations, that is N plus sodium ions and anions, they are surrounded by these water molecules. You can see I have shown here, and there exist these ion dipolar interactions. So both sodium and these chloride ions get hydrated, and they are represented by, we represent them as n plus aqueous and Cl minus, this is Cl minus aqueous. So aqueous ions. So during a hydration of ions, certain amount of energy is it is given out, and this energy is we call as hydration energy, and this energy is given out due to the attraction, and this accounts for the solubility, this accounts for solubility of this NaCl in water. So this is about ion dipole interaction. And then we have got ion induced dipolar interactions and instantaneous dipolar interactions. We will discuss these two in our next lecture. This is for today. Thank you very much.